Greetings to everyone. I'm Ram Prasad from the team of RoboFlight. We have chosen a problem statement. The problem statement is disaster response drone in remote areas. This problem statement has been released by the government of Odisha to address the critical challenges in their emergency relief conditions. The solution for the problem statement is rapid air drone, a smart medical and food supply drone in a disaster zones. Let me describe about our problem solution. It's the drone which has the octocopter frames and a pixel flight controller to enhance its stability as well as the safety for the drone. And let me explain about the uniqueness and innovation of our problem solution. Firstly, we have integrated a thermal cam and a vision cam to detect the peoples as well as the type of disaster which has been faced in the situation. Next, we have integrated the speech to text format to communicate between the some affected peoples or the peoples who have been affected in the area. Finally, we have integrated area mapping system. The system which helps to send the live coordinates or a live feed to the rescue team to rescue the people who have been affected. Technical approach. We have three phases of technical approach. One is drone operation, second phase is control and ground control and AI, third phase is rescue and response. In these three phases, we have several steps. First, the drone has been scanned the area, and the scanned area has been sent to the ground control. Phase 2, ground control. In the ground control, the captured image has been sent to the ground control. Right? The ground control will be pre-process the image, and they will be feed the live information to the rescue team. And in the rescue team and the response. In this, the sent coordinates or the sent feed has been monitored and has been pre-processed with the rescue team, and they will be go and rescue the people who have been rescued. Right now, we can just see about the system architecture and kit components. If we have come to the system architecture and kit components, there are four major categories. One is drone hardware, flight controls and AIs, payload and communication, and ground control and software. These four are the major parts. First, we can just look over for the drone hardware. Drone hardware is nothing but 8 octa frames, that is 8 propellers with a high power and high speed motors. To supply the power, we are just using lithium-ion battery. Then flight control and AI. To flight control and AI, we are using a Pixar, which is a high-end flight controller, which is used for the larger monitoring systems, like larger drones. That is we are using. And then, if you come for the AI, we are using speech to text integration format. This is used by I2S microphone. This is basically like if you are given a speech, it will convert into the text and it will be displayed in the display monitor. After that, we are using autopilot for the similar. Basically, if you look for the next, we are using autopilot. This is for the automation of the drone or to communicate with the drone. Next, here comes the payload and the communication. Payload is nothing but how much the weight has been lifted or how much the things has been stored in the drone. We are using COM node as well as the payload bay and release system. Payload bay and release system is nothing but unloading and loading of the weights. Next, here comes the ground control and software. We are using a custom app to monitor the drone, monitor the area like aerial monitoring, as well as the how much weight it is lifting and people coordinations. Let me explain about the drone design. Here comes the drone design. This is what we have designed it. Basically, in our drone, we have 8 propellers. That is, our drone frame is an octocopter frame. This is the main central body of the drone. We are integrating 2 lenses in the cam. One is thermal cam and another lens is visual cam. This is what the payload capacity. We are just designing of a drone of 20 kgs, which have a capability of designing like lifting 5 kg, minimum of 5 kg payload. This helps to lift the medical expenses like food supplies, everything which we need to provide for the disaster zones. Right now we can discuss about the feasibility and viability of the problem solution. First, we can discuss about the feasibilities. there are different feasibilities like technical feasibility, operational feasibility, design feasibility. These are the feasibilities. And if you come for the viabilities, financial viability, market viability, and problem solution viability. Basically, what is feasibility? What is viability? This is the topic where which the people can be getting note of that whether this project can be implemented or not. This is basically. Here, first we can check about the technical feasibility. In technical feasibility, we are using open source flight control systems and ensuring the solid and technical foundation. This helps to result that technically we can able to do this project. That is technical feasibility. Then operational feasibility. Operational feasibility is nothing but whether it can be operated in the areas like disaster zones or the places where this problem solution can be work. This is operational feasibility. Financial viability. Financial viability. To discuss about the financial viability, we need to come through about the breakthrough of our financial things. Basically, in this financial viability, like our project is asked at higher cost because we are making a drone of 20 kgs. So its minimum costing will be around of 3 lakhs. In this, we can able to do within 3 lakhs. This is the topic which discuss about the financial part is called financial viability. Next here come market viability. Market viability is nothing but we are just looking that whether this drone is already exists or not. That is the market viability. If you come through it, there is a drone called drone already exists based on this problem solution. But we have some uniqueness as we have discussed it before itself. Next, design viability. Upcoming slides we will be discussing about the drone design. Same like that, this is the basic component which knows to that whether this design will be possible or not. That is the design feasibility. Next, problem solving is viability. Problem solving viability is where the drone based supplies and the communication supports makes the higher efficiency here. Like drone based supplies, that is the payload. And then communication support. Communication support is nothing but communicating between the ground station and the affected people. Right now we can come to the impacts and benefits part. Impacts and benefits. Basically nothing but impact. What kind of impact does our problem solution given, and benefits. Benefits nothing but what are the benefits has been given by our problem solution. Basically I was just coming through the general over impacts. People who have been affected cannot be rescued at the certain times. They can be rescued or they can be monitored by our problem solution. Benefits nothing but as I have mentioned before, weakness of our problem solution. Basically using thermal cams, we are detecting peoples. Using visual cams, we are detecting the types of disasters, and we are lifting the payloads like food supplies, medicines to the affected peoples. We are using speech to text transformations to communicate between the affected peoples. These are the benefits with our problem solution. On behalf of RoboFlight, I am thanking everyone for giving this wonderful opportunity.